morning. Welcome back to the laboratory demonstration session of the course Engineering Metrology. So, the next instrument I will pick here is the thread gauge or pitch gauge. So, let us recall the screw thread terminology before I show you the actual tool here. So, this is the screw thread terminology. Here we have the major dia, this is the major dia, the minor dia, the minimum dia, and we have pitch diameter. Okay. So, there is root and crest, we have trough and crest. The distance between the two roots or two crests is known as pitch. Pitch is actually with one rotation, with a single start thread, with one rotation, one complete rotation, that is 360-degree rotation, how much forward does our thread go? How much forward does our screw or our nut go? Okay, that is our pitch. Okay. So, there is an angle here, this is known as chamfer angle at the end of the screw. Here we have the chamfer. So, we have various angles here, this is known as thread angle, we have a helix angle, this angle is helix angle. Okay. So, this 2 alpha is our thread angle. So, the depth of thread is the distance between the crest and root, and major dia is an imaginary largest dia of the thread. Then we minor dia is the imaginary smallest dia. Pitch dia is a theoretical dia between the major and minor diameters. Then we have helix angle, it is on the straight thread, it is the angle made by the helix of the thread with the pitch line, it is the angle made, helix angle is the angle on the straight thread which is made by the helix of the thread at the pitch line with the axis. So, this is helix angle. So, these are various components. Next I come to my gauge, the screw gauge. This is our screw gauge. If I open it, you will see the various leaves here which are very similar to the feeler gauge, but the difference is that the thickness of each leaf is same, but we have different profiles of threads here. I would like to correct myself, it is different pitches of the thread, the profile is same, it is actually the metric, it is metric thread gauge. The metric thread that we can have metric thread gauge, Acme thread gauge, then Whitworth thread gauge. For all different kinds of threads we can have different thread gauges, and this is a metric thread gauge which is having range from 0.25 to 2.5 mm pitch. The smallest leaf here has the pitch 0.25 mm and the largest leaf is 2.5 mm. So, this feeler gauge or the thread gauge, these small gauges, which is that instrument which are used for very quick measurements, so very quick inferences. This feeler gauge can just tell us, okay, what is the gap. We can measure the gap in many other ways, like we can just use, if the gap is larger, we can use vernier caliper or certain other methods could be there. We can measure the pitch of the thread using other metrological methods, but the thread gauge is one instrument that will just give you quickly, okay, what is the pitch. So, we can see, okay, I have a spark plug here on which I will apply this screw gauge. So, let me try to fit which of the leaf is fitting properly here. So, I know that this spark plug is having metric type of profile only. So, okay, let me try this one. This size is 1.1 mm pitch. So, you can see that 1.1 mm is a little larger. This actually the pitch on the leaf of my thread gauge is a little larger. So, let us try 1 mm. It looks like a good fit, it is fitting properly. To confirm it, we will use the rule of go and no go gauges. So, I think it is 1 mm, the pitch of this the screw of the spark plug is 1 mm only. I will confirm it by using 0.9 mm also. you can see the 0.9 mm is a little smaller. So 1 mm is the proper pitch here. So the through gauge is also sometimes known as screw gauge. However, the micrometer is also known as screw gauge. It is also known as pitch gauge. So it is used to measure the pitch or lead of any screw thread. So the thread pitch gauges are used as a reference tool in determining the pitch of a thread that is on the screw or in a tapered hole. It may be used to measure the internal or external threads, both whatever we desire. So this is one of the instruments that we selected to show you. So next instrument I will pick here is spirit level. Spirit level is an instrument it is simply a level or an instrument that is used to see whether the surfaces are horizontal or vertical, or is there any difference in the level or not. It is used by carpenters, masons, or for taking the brick line, that is the wall getting straight or not. You might have seen that, and in mechanical metrological lab it is also used sometimes. So the spirit level that we have here is a 12-inch spirit level. The length is 12 inch. It is having various components. It has a bubble in the vial. This whole component is known as vial, this cylinder, in which we have this bubble, and in this we have a viscous fluid. This fluid is generally an ethanol or something, anything that is colored. Okay, it is a fluid that is a low viscosity fluid, and it is generally some alcohol like ethanol. So it is colored so as one can clearly see that is the bubble in the center or not. So this spirit level is sensitive to the temperature. The sensitivity to the temperature is from -20 degree to 60 degree centigrades. So it is -20 degree to 60 degree centigrades. Actually, this fluid is also known as spirit. That is why it is known as spirit level. So it is colored, and also a luminescent reflector is kept behind the vial so as the observer can clearly see or a light, it illuminates and it can be clearly seen. So the spirit level has a small principle in its operation. See, when we move it, you can see the bubble is changing its position, and also there are two vials for the vertical level as well. The two vials to see the vertical level as well. So it is calibrated based on this surface and this surface. So actually this specific instrument is calibrated for both the surfaces. In general, spirit level is calibrated based on only one surface, and if it is this surface which is the reference surface based on which it is calibrated, it has to be always used based on this surface. For instance, if I need to see a level from the bottom side and this is not the calibration, this is not a reference surface, it wouldn't be a good practice to use it like this if I need to see at the bottom side. Because this is a reference surface, we have to turn it upside down, and this reference surface has to be touched with the base to see the spirit level. Okay. So there is a principle for the vial. Actually, the vial is not a straight cylinder. The vial is a little convex in the shape. So if I draw this as my spirit level, this is 12 inch, and this vial, the distance between the two lines, you can see the two markings are there, two black lines are there on the vial. You can see closely that there are two black lines. Okay, the bubble has to remain within these black lines. There doesn't have to be any parallax error. So let me make it very parallel to the camera. Okay, now you can see the bubble is exactly in the two lines. Okay, so because of the parallax error, it was it looked like that, okay, it is not aligned properly, okay, it looked like that it is aligned on this side, this direction, okay, but if I make it parallel to the camera or straight perpendicular to the camera, it is touching properly. That means the surface plate is properly grounded, or not properly grounded, it is actually straight or parallel to the ground. So these markings are generally from 2 to 10 mm. Now the vial is not a straight cylinder like this. There are markings here and there is a bubble here. If it is a straight cylinder, you know, if it tilts like this on this, the bubble wouldn't find a space to stay here. It would just keep on moving here and there. So the shape of the vial is something like this. It is a kind of an oval shape, and the bubble would always try to find the stable space. So when you move it up and down, not up and down, when you tilt it actually at some angle, the bubble would change its position, but when it is at a level, when it is parallel, bubble will stay at this position. However, it is not sure if it had been a straight cylinder, it wouldn't be sure that it would stay here or wherever it could go. There are two markings here. So the larger is the radius, means the bubble can move more easily and reacts to the smaller movement sensitivity, more sensitivity. You can take it through as a reference to the cylinders. You know, if this is a center point, so this is a center point and this is a circle here. So let me say this another circle, this another circle here. So larger this radius, the more sensitive is the spirit level. So I can explain this using the principle of the spirit level here. So what happens if my bubble is here, this is my bubble, okay, it changes its position from B to B dash, and this change in position, this length is L, and the radius of the vial is, let me say, R, this is center, the radius is R, this angle is the angle that the two ends of the bubble or two ends of the line make with the center of the circle. I call this angle as alpha. Now what happens when the spirit level is parallel to the ground here, there is no movement. If I make some movement, let me say this movement is alpha. Actually this movement is because of this alpha is same because this line is perpendicular to the base. So whenever it is moved at an angle alpha, the bubble will move an equivalent angle. When I move it at some angle, the bubble will also make the same angle with the center of the vial. So this angle alpha and this angle with the base, this is same. So this angle, that is angle at which the spirit level is tilted, if I tilt it like this, okay, I will keep my pencil stationary and make it straight, okay, this angle alpha and this angle that the bubble makes with the center of the vial, this angle is same, this alpha, okay, with the center line and this alpha with the spirit level. Based on this principle, the spirit level works, and this, if this is line L and it changes at any point, let me say at the end, it changes its position from A to A dash, and this height is h, you know that theta is equal to L by R, okay, the arc length. So this is an arc, actually L is arc here, arc length is equal to the length of the movement by the radius. So, this is a general formula. So, here the angle is alpha, this alpha is equal to L by R. Okay. This L is arc length, R is the radius. So, also we can see that H is equal to L into alpha. So, this makes L is equal to R H by capital L. So, this is equation 1 and this is equation 2. So, that derives the equation 3. With this we can find the sensitivity of the of our spirit level. The sensitivity can be in the order of seconds. So, it might be some seconds. Okay. So, we can just see, okay, when does this bubble move. So, as you know, we had that wire, the dia of which we measured using vernier caliper. This wire, the dia of the wire is 4 mm. Let me try to put this wire on the end of the spirit level. So, it is put at the extreme end. So, do you find any movement in the bubble? So, has the bubble crossed the marking? Yes, it has crossed. So, that means this 4 mm is quite a large height to quite a large length to make it move. So, the sensitivity is that at what point, at what movement does the bubble starts moving. So, you know, if I do make a small movement like this, I make a very small movement, it is not moving, it is not marking the line. So, I can check it using the feeler gauge as well. So, this was the feeler gauge. We had various dimensions there, it is 5 to 80, 5 by 100 to 80 by 100. So, the finest leaf here is 5 by 100. So, let me try to put this 5 by 100 leaf here at the end. Do you find the movement in the bubble? There is no movement. That is 5 by 100 mm, it does not move. So, let me try to increase the thickness, this one, okay. So, this length I have put another leaf here, this is actually 25 by 100, this is 0.25, it is still not moving, okay. I will take it off. So, let me try to put this, the thickest leaf, the coarsest leaf here, which is of the order of 80 by 100, 80 by 100 is 0.8, 80 by 100, okay, the coarsest leaf. Do you find any movement in the bubble? Yes, the bubble has touched, or it is trying to cross the line here, it is trying to cross the line here. So, that means 0.8 is not acceptable and 0.25 is acceptable. Let me try to pick some, I am just doing hit and trial method, let me try to pick 0.5, 0.5 is, okay, let me try to pick 0.5, 0.5 is it is not acceptable, it is making some movement here. So, let me try to pick 0.3 here, it is acceptable I suppose. So, 0.3 acceptable, 0.3 sorry 0.3, 0.3 okay, 0.3 acceptable, 0.5 not acceptable, 0.4 leaf we do not have here. So, we can find okay 0.3 mm, this movement, this is length of h actually, you know, I am moving it up and down this height, okay, 0.3 mm is acceptable and 0.5 mm is not acceptable. So, I can take an average 0.4 mm, okay, then h is equal to 0.4 mm, this length L is equal to 12 inches, which is equal to 300 mm. Okay. Alpha value we haven't calculated. Okay, we can calculate alpha using the equation number 2. We can calculate alpha is equal to h by L. Now, this is 0.4 by 300, which is equal to 0.00133 radians. Okay. So, this much radians, and this is alpha. Okay. The value of r, that is the center, the curvature of the vial. This is the curvature of the vial. When it meets the center point that it meets, this varies. So the radius of curvature, if this is the vial, this is the curved surface of the vial, the radius of curvature, this r value that is given here, this varies from 30 to 10,000 mm. Sometimes the curvature is not, sometimes it can be certain hundreds of meters as well. Okay. I have just put it here 10 meters. Okay. In generally it varies like this. Okay. So, we can calculate the sensitivity, okay, by moving 0.4 or by 0.4 mm of movement, it is the angle that is covered is 0.00133 radians. Okay. So, for 1 mm, movement, the angle would be 0.0133 by 0.4. This would be equal to 0.0032. So, this can be a kind of sensitivity of this instrument. Okay. However, this is not the exact calculation, we have just made a hit and trial method. So, this sensitivity of the instrument can be calculated using this relation or this principle. So, this is the spirit level. Another precautions or guidelines for the spirit level is that whenever we need to use the spirit level, we can check the level in this direction, and also we turn it 180 degree to check if the position of the bubble changes. So, this will tell us that is the spirit level, this instrument properly calibrated or not. Okay. This was one thing. Second thing I have taught you, I have always said that if this is the reference surface, we cannot use this surface from the bottom. Okay. It has to be like this. So, we have to see that it is between the lines properly. So, these are certain precautions we can, so it can be used to mark lines, vertical lines, using this proper vertical lines, okay, vertical markings, and sometime a few vials in the spirit levels are also at 45 degree here. Sometimes the vials are also at 45 degree here. So, this 45 degree angle would let us to mark the 45 degree angle directly. So, this is the use of the spirit level. So, this was the discussion about the spirit level, that is one of the instruments that we discussed. So, I will take a break here and we will meet in the next part of the laboratory demonstration, where I will discuss another instrument. Thank you.